Hello everyone, how are you guys? So welcome back and very good afternoon to all. I'm C. Gaurav Chopra in the brand new session of ICI. And in today's session, we are going to start with our topic integration, that is integral calculus. So welcome back everyone and very good afternoon. So let's see who all are live with us now. Sahil Khan Pathan is there, Sonali, Gunjan Devi, Bhumika, Divya, Diksha, Priyanshu, Rohini, Pratik, Sarvaswa, and a lot more. So, very good afternoon. So, welcome back, everyone. So, in today's session, we are going to discuss about integration. Now, integration is simply the reverse process of differentiation. Integration is simply the reverse process of differentiation. So in integration, one function was given like fx. So fx was one of the function, it was given. And after differentiation, we got f dash x. fx was the function. जब हमने उसको differentiate किया, we received f dash x. That was the previous chapter. But now in this chapter, we will be having f dash x and we will reach till fx. हमारे पास f dash x available होगा and after integrating this we will get fx. So in the chapter differentiation, from fx we reached f dash x. That was differentiation. But here from f dash x we will reach fx. This is integration. So that is why we say that it is reverse process of differentiation, or it is also known as anti-differentiation. Integration is also known as anti-differentiation. Okay. So now Zeva is also live. Gareza, Sahajpreet, Achal Singh, Sakshi, Manvi, Sanjana, Vinutha, Abhinav, Manvi. Okay, great. So now, first of all, we have to learn the process, the formula, how do we integrate? Okay, so we will focus on the first formula first. And before moving towards the formula, what is the sign of integration? So for integrating, we use the symbol and we write whatever function is given, and at last we will write dx. This simply means integrating with respect to x. Whenever this symbol is written, this means integrating with respect to x. Just like as we read in the previous chapter, like d by dx of any value. That was integrating with differentiating with respect to x. That was differentiating with respect to x. But now here we are using integration with respect to x. All right. Okay. So now Chitrank is also live. Rahul, Lakshmi, Kushdeep, great. Now let us learn the first formula. The first formula for integration. Let's say if we have to integrate x to the power of n, and at last dx is written. So if we have to integrate x to the power of n, so what we have to do? The power will increase by 1 this time. In differentiation, we reduce the power by 1. But here, since the process is reverse, we will increase the power by 1. So we will write n plus 1. And then divided by the same power, that is n plus 1. Dividing by the same power, that is n plus 1. And at last, we have to write one constant, that is c. We have to always write one constant, that is c. Now the question is, why do we write this constant? Why do we write this constant? So before that, we will take one example of differentiation. Let's say if we have to differentiate x square, this is fx, and now we have to find f dash x, that is differentiation of x square. What will come? It will be 2x. It will be simply 2x. And if we, let's say, differentiate x square plus 2, now what will come? It will be again 2x. If we differentiate, let's say, fx is equal to x square plus 100, this time what will come? So f dash x will be again 2. Differentiation of constant is always equal to 0. So that is why in each and every case we have changed the constant. In first case there was no constant, that means the constant was 0. In second case constant was 2, and in third case constant was 100, and we got the same result. Now if we integrate them, then see what happens. Integration of 2x dx. Now this, since 2 is getting multiplied with a variable, so this 2 will remain as it is, and now we have to integrate x. So according to formula, power will increase by 1, and we have to write the same power in denominator. Now see what will come. 2x square by 2. We can cancel the 2. We are getting x square. But we are unable to get that constant. This x square is the result, but what about the constant? Constant is 0, either 2 or 100. What is the constant? We don't know. That is why we always keep c as the constant. So after integrating any f dash x, we have to always use a constant, and that is denoted by small c. All right. So most of you have given the answers. That's great. So integration of 2x is simply x square plus c. So this was the first formula, and this is one of the most basic formula for integration. So x to the power of n is equal to x to the power n plus 1 divided by n plus 1. And then at last we will use plus c. Now let us see some more formulas. Now the most important thing in this first formula is the condition. When this formula is not applicable. This formula is not applicable when n is equal to -1. So the condition says this formula is correct, but n should not be equal to -1. Now why so? If it is equal to -1, then what will happen? So let's try. If it is given x to the power of -1. Now according to formula, we have to increase the power by 1. So we will add 1 and divide it by the same power. Now as soon as we see the result, we are getting 0 in denominator, and anything divided by 0 becomes indefinite. It becomes indefinite, it becomes infinity. So that is why we cannot use this formula when n is equal to -1. Okay, so we have to remember that this first formula, x to the power of n, cannot be used when n is equal to -1. All right. Yes. So Divya says clear. Rahul says yes, it is exactly reverse of differentiation, right? Manvi is asking some question about differentiation. See, we are doing integration now. Now the second one, dx. Now if we have to integrate, let's say 1, only 1 is there, and we have to differentiate it. Now what is the integration of 1? Since we have to integrate with respect to x, we can write 1 as x to the power of 0. 1 can be written as x to the power of 0. While integrating, we know that we have to increase the power by 1 and divide it by the same power and then add the constant. So what is the result? It is simply x plus c. So integration of 1 is equal to x plus c. Integration of 1 is equal to x plus c. All right. So this becomes the second formula. Now third one, e to the power of x, the most easiest one. So whenever we are talking about exponential function, e to the power of x, its differentiation is same, its integration is also same. So we can write e to the power of x and then plus c. Always add the constant. This was formula. Now, if some values are attached with e, then what will happen? So now, if the question says, or if the formula says e to the power of ax, now how to integrate this? How to integrate this? So first of all, we will write e to the power of ax as it is. Now we have to divide by the differentiation of ax. Now what is the difference? So we know that differentiation of ax is simply a. So we will divide it by a and then write the constant. So this becomes the formula. Okay. So e to the power of ax dx is equal to e to the power of ax divided by a, and then we will add the constant. So this was formula number 4. Now coming to the next formula. So what will happen when we have to integrate x to the power of minus 1? How to integrate this? So there will be a different formula for this. So this can also be written as 1 upon x dx. 1 upon x dx. Now what is the integration of 1 by x? It is simply log of x plus c. Now if we recall, what was the differentiation of log x? So we had written 1 by x. Similarly, what is the integration of 1 by x? It is simply log of x. So both are reverse of each other. So integration of 1 by x is log x plus c. And then comes the sixth one, integration of a to the power of x dx. So here we will write a to the power of x divided by log of a base e, and then adding the constant c. All right. So these are the 6 basic formulas. And in the answer for all integrating sum, we add plus c, that is constant, since the differentiation of constant is always equal to 0. That is why we will always add the constant after integration. All right. So I think you have learned all the formulas, because we have to learn immediately. If we learn immediately, we will be able to solve each and every question now based on these formulas. So let us try some questions based on these. And also some basic rules are also there. If any constant is getting multiplied with all these, then what will happen? For example, if we say it is 2 to the power of x square, and we have to integrate this. So whenever such constant is there, keep the constant outside, because it will remain as it is. Now we have to integrate x square dx. Now what is the integration of this? To x square will become, power will become 2 plus 1, and denominator also 2 plus 1, and then adding the constant. So 2 x cube upon 3 plus c to x cube upon 3 plus c. This becomes the result. So whenever constant is there, keep that constant separate. All right. Then the next thing is addition and subtraction. If let's say two functions are there and then in between there is addition or subtraction, then what we have to do, like the question says, find out the integration of x cube plus 5x square plus 10. Now if we have to integrate them, now first of all, first thing is we can separate them. It will become x cube dx plus 5 integration of x square dx plus 10 integration of dx. And then what we can do, we can solve them. X to the power of 4 divided by 4. Then 5 x to the power of 3 divided by 3. And then 10. Now 1 can be written as x to the power of 0. It will become x. And then what about constant? Now we don't have to write separate constant for each and every one. So we can write a common constant, that is c. So this will become the result. So whenever more than two functions are there with plus or minus sign in between, we can separate them. We can easily integrate them separately. All right. So this was the basic question. Now let us try some more questions from the study material. Now integration of root of x. Let us try the first one. Integrating root of x dx. This is the question. Now this can also be written as x to the power of half. Square root means power half. Now whenever we have to integrate, increase the power by 1. And then in denominator, the same power will be written plus c. So what will happen? X to the power of 3 by 2 divided by 3 by 2 plus c. And this can also be written as 3 by 2 will become reciprocal 2 by 3, and then x to the power of 3 by 2, and it can also be written as x root x. One and the same thing. We can write x to the power of 3 by 2 or x root x. The result is same. So Kushdeep has given the answer. Harnul, Bhumika, Divya. Yes, all of you have given the answer. Jia Patel has also given the answer. Then Anushya Bhatt has also given. Great. Ustad is asking about how to ask the doubt. Yes, you can download the app Students Clinic and you can ask the doubts from there. So this was the first one. Let us try the second one also. Second is integration of 1 upon root x dx. 1 upon root x. This can also be written as x to the power of minus half. X to the power of minus half. Now power will increase by 1. Okay. Now what will be the final result? It will be x to the power of half divided by half plus c. Half will become reciprocal to 2 root of x plus c. 2 root x plus c. This will become the final result. All right. So I think everyone is able to understand all these basic concepts, because if we don't strong this basic concept, then we will not be able to solve the lengthy question or the tricky questions from back. That is why we have to strong our base first. Okay, now the third one, e to the power of minus 3x. E to the power of minus 3x. So first of all, what is the derivative of e? Sorry, integration of e, it will be same, e to the power of minus 3x. Now this 3x minus 3x we have to differentiate and then divide here. So what is the derivative of minus 3x? It is minus 3 and then add the constant c. That's it. Only one step and done. Let's try the fourth one. Integration of 3 to the power of x. Now here we can apply the formula of a to the power of x. So what will happen? A to the power of x divided by log of a base e. That means log of 3 with base e, adding the constant c. So 3 to the power of x divided by log 3 plus c. Okay. Now let's try the fifth one also. X root x dx. Now this can also be written as x is having power of 1, root x is having power half. If we combine them, then what will be the power? X to the power of 3 by 2. So we have to integrate x to the power of 3 by 2. So power will increase by 1. So 3 by 2 plus 1 divided by also 3 by 2 plus 1 and then adding the constant. So x to the power will become 5 by 2 divided by 5 by 2 plus c. So final result can be 2 upon 5 x to the power of 5 by 2 plus c. And 5 by 2 power can also be written as x square root x. So we can write in any form as per our requirement. Okay. Divya says all done. Bhumika has given the answer. Harnoor has given. Zeba has given. Great. So till here, everyone has done. Now let us come towards the next part, having a bit of more steps question. Now this time the question says integrate x plus 1 upon x whole square dx. X plus 1 upon x whole square dx. So since it is whole square, we can easily open the whole square. So a plus b square is how much? A square plus 2ab plus b square. So we can open this. So a square plus 2ab and then plus b square, that is 1 by x square. Now we can integrate them separately. For x square will become x cube upon 3. And second one, x and x will get cancelled. We are having only 2. So integration of 2 is 2x. And then 1 upon x square. 1 upon x square means x is having power -2. So we will increase the power by 1 and divide with same. At last, adding the constant c. So what is left? X cube upon 3 plus 2x and then minus x to the power of -1 plus c. And x to the power of -1 can also be written as 1 upon x. So this is the final answer. Okay. Divya Kumari is saying your handwriting is nice. Thank you so much. Diksha Agarwal is saying it's easy. Yes, in reality is also easy. So in each and every chapter, the most important thing is always the basics. It can be any subject, any topic, but importance is of basic. If we understand the basic carefully, then we can try ourselves each and every question from the back. There is no worry. So the most important thing is to understand the basics. After that, we have to just apply the different formulas and get the result. All right. Okay. So now let's try the next one. So this time we are having different variety of question. So let's try the next variety. Question says integration of root x and then x cube plus 2x minus 3 dx. This is given. Now these are two different functions getting multiplied. If we are able to multiply them, then it is always better to multiply. It is always better to multiply them. So let us multiply. Root x means x to the power of half. Okay, so we are multiplying root of x with x cube. So whenever we are multiplying two things having same base, the power will get added. Power will add. So what about the power of x? 3 plus half. It becomes 3.5. It can also be written as power 7 upon 2 plus 2. Then x and root x. X is power 1. Root x is power half. Adding them will give 1.5. So x to the power of 3/2 minus 3 root x. So it can be written as 3 power half. Now we can integrate them one by one. So x to the power of 7/2 plus 1 upon 7/2 plus 1 plus 2 will remain as it is. X to the power of 3/2 plus 1 divided by 3/2 plus 1 minus 3 x to the power of half plus 1 divided by half plus 1. And at last, a common constant, that is c. Common constant c. Now let's simplify them. So what we are getting, x to the power of 9/2 divided by 9/2, or we can write it as 2/9. Then 2 multiplied by x to the power of 5/2 divided by 5/2. 5/2 will become reciprocal, that is 2/5 minus 3 x to the power of 3/2 divided by 3/2. It will also become reciprocal and become 2/3 plus c. Now we can cancel some of the things. Let us try to cancel. So 3 and 3 will get cancelled here. and whatever is left become the final answer. Okay, so the final result we are getting is 2x to the power of 9 by 2 upon 9 plus 4x to the power of 5 by 2 upon 5 minus 2x to the power of 3 by 2 plus c. Yes, Chitrang Sharma has given the answer. Sahaj Preet has given. Bhumika, Zeba, great. Then the third example I think you can do. We have done this type of pattern. Now the fourth one. Let us try the fourth one now. X squared divided by x plus 1. X squared divided by x plus 1. So we can try that. Let's make some space here. Okay. So now the fourth one says integration of x squared divided by x plus 1 dx. Now we have to see these two functions are into division. These two functions are into division. Now how to solve them? So there are some tricks which we can use. So since in denominator we are having x plus 1, but in numerator we are not having x plus 1. So if we try to make x plus 1 in numerator, then it can get cancelled. It can get cancelled. So let us try to make x plus 1 in numerator also. So what we are doing first, adding 1 and subtracting 1. X square, adding 1 and then subtracting 1. And then divided by x plus 1. So this is the first step we have done. Added and subtracted. This means this makes no difference, but we can split them now. Now how to split them? Let's see. It will become integration of x square minus 1 upon x plus 1 dx plus integration of 1 upon x plus 1 dx. So in this way we have splitted them. Now what can be done? X square minus 1 is there. So it can also be written as x square minus 1 square. So a square minus b square, we can apply the identity. So it will become a plus b and a minus b. So let's try a plus b, a minus b. And then in denominator, we are having x plus 1. So now x plus 1 is getting cancelled. What is left? Integration of x minus 1. So what is the integration of x first? For x it is x square divided by 2 minus. What about 1? It is simply x and 1 upon x plus 1. So we have learned the formula. Whenever 1 upon x is there, it is written as log x. 1 upon x is log of x. So we can write log of x plus 1. Log of x plus 1. And then adding one common constant c. Okay. So this becomes the final formula. Okay. So now there is one doubt from Ustad Singh. Ustad Singh says, please repeat step 1 of second question. Okay. Second question was this one. This was the second question. Let us select. Yeah, so in this second step, what we had done, first of all, we had multiplied. Root x was multiplied with a complete bracket. We have multiplied root x with the whole bracket. And after multiplying, we got the powers. So since x is having power half and x is having power 3, both the powers will get added. So x will become power 3.5, or we can write 7 by 2. So in this manner, first of all, we have multiplied, and after that, we have done integration. For integration, adding 1 in power and then dividing by the same power. All right. Devansh says in differentiation, if the constant is 3, 5 or anything, it gets eliminated. And in integration, we write c at the end of the function, right? So in integration, we are adding the constant, whereas in differentiation, the constant automatically gets eliminated because differentiation of constant is always equal to 0. But here, integration of constant is equal to x. If it is 1, it becomes x. If it is 2, it becomes 2x. If it is 5, it becomes 5x. Okay. Okay, now there is doubt from 3 persons. Sonalika, then Kushdeep, Lakshmi, Koshti Deepak Bhai, then Manvi. Okay, so all of them are asking this fourth question. All right, so let us try the fourth one once again. So the first step was we are having in numerator x square and denominator is x plus 1. So here there are two functions and getting divided. And in denominator, we are having x plus 1. Now, if we have to remove the value from denominator, we require x plus 1 in numerator. All right, we require x plus 1 in numerator. So that is why we have added and subtracted 1. So this is minus 1, and then plus 1. After that, we have splitted that. We have done the splitting. So till here, we have taken in first portion, and after that, we have taken in second portion. So it became x squared minus 1 upon x plus 1 and 1 divided by x plus 1. This we had done. Now, since we are having x squared minus 1 in numerator, so we can apply the identity of a square minus b square. It is simply a plus b multiplied by a minus b. So we can write x plus 1 and x minus 1. So that's why we have written x plus 1 and x minus 1. Now, since we have got x plus 1 in numerator also, we can completely eliminate them. So after elimination, what we have got is, we have got x minus 1. And here it is 1 upon x plus 1. Now we have to integrate x. So integration of x is x squared by 2. Integration of minus 1 is minus x. Then integration of 1 by x plus 1, we have to use log. So log of x plus 1. And at last, adding the constant. So this is the final result. All right. Okay. Next is Manvi Khanna from Punjab asking fifth part, please. Okay. Yes, we will do the fifth one also because fifth is a different question. Now, in the fifth portion, this time what we have to do? We are having x to the power of 3 plus 5x square minus 3 divided by x plus 2. So power of numerator is, maximum power of numerator is 3 and maximum power of denominator is 1. So can we divide them? Yes, of course we can divide them. So we have to go into flashback class 9th and 10th, and we have to recall that how to divide algebra, right? So we can easily divide them first. So let's try here division. So x cube plus 5x square minus 3. And we have to divide this with x plus 2. Divide with x plus 2. Now, this is here the maximum power is x, and here it is x cube. So we have to multiply with x square in order to make it x cube. So multiply it with x square. So it becomes x cube plus 2x square. Subtracting, subtracting. What is left? X cube will get cancelled, and we are left with 3x square minus 3. 3x square minus 3. Now this time we have to make 3x square. So we can add 3x. So 3x will get multiplied with both of them. So 3x square plus 6x. Again subtraction. So here 3x square will get cancelled. What is left? Minus 6x minus 3. Now we require minus 6x. So minus 6x we can write here minus 6. So minus 6 is getting multiplied with both of them. It will become minus 6x and then minus 12. Changing the sign and then cancellation. So what is left? Remainder is 9. So the first step was division. First step is division. Now the second step. Second step is how to write them. So we can write them as x square plus 3x minus 6. This is the complete result. And after that, we are left with remainder divided by the divisor. So in this manner, we have written the question. Okay. Now it becomes easy to integrate. The first step was division, and after division, now we can easily integrate them. So let's do this. X square will become x cube upon 3. 3x will become 3x square upon 2. Minus 6 will become minus 6x. Then 9 is constant, it will remain as it is. Now 1 upon x plus 2. So whenever 1 upon x formation is there, we have to use log. So it is log of x plus 2. And at last, adding the constant c. Okay. So whenever 1 upon x form is there, so it is important to remember the formula, that is the logarithm. There is no other formula. So Samir is asking the same thing. It is important to write the log. Yes, it is important because the formula is there with log only. So you can note down the division if in case you don't know how to divide. Ustad says, thank you, sir, for making it simple. That's great. Now, Now the next method is method of substitution. Method of substitution. Now whenever a function and another function is given, when two functions are joined together, then we can use substitution method. So here there are variety of method, substitution method, or even we can use the chain rule. We can do integration by parts. So many different methods are there. So the next method which we are doing is method of substitution. Okay. So let's do this. Now integration of, we have to do 2x plus 3 whole to the power of 7. Integration of 2x plus 3 whole to the power of 7. This is the question. Now what we have to do, the first function is x to the power of 7. That is anything to the power of n. That is the first formula we have to apply here. And then the second function here is 2x plus 3. So again, we have to apply the formula here also. So there are two functions clubbed together. There are two functions clubbed together. So this time, what we have to do, let's see. So first of all, we will assume the given one of the function as t. So let 2x plus 3 is equal to t. So we have taken this function as t. Now what we have to do, differentiating with respect to x. We have to differentiate with respect to x. So what will be the differentiation of 2x? It will become 2. What about 3? It becomes 0. And what about t? It becomes dt by dx. For t, we can write dt by dx because we are differentiating with respect to x. Now, from here, we can see that dx can be written as dt by 2. Dx can be written as dt by 2. So this we have done the first step. Now what about the second step? In second step, we have taken 2x plus 3 as t. So therefore we will write here t to the power of 7 and dx can be written as dt upon 2. dt upon 2. So 1 by 2 is the constant getting multiplied. It will remain as it is. Now the integration of t to the power of 7, it becomes 7 plus 1 divided by 7 plus 1. So what is left? It is t to the power of 8 upon 16 and then plus c. Plus c. And at last we can again substitute the value of t. It becomes 2x plus 3 to the power of 8 divided by 16 plus c. So this method is known as substitution method. All right. This method is known as substitution method. Okay, that's great. Integration, and everyone is saying it's easy. That's great. Because most of the people are getting scared with these two chapters, differentiation and integration, but you guys are outstanding because each one of you is saying it's easy. That's great. So this method is known as substitution method. So let us try one more question from this so that you can get more idea how to solve using substitution method. Let's take one more question. Now this time we have to, let's say, integrate 5x minus 7 to the power of 3. 5x minus 7 to the power of 3. So if we apply the same thing once again, so let 5x minus 7 is equal to t. This is the first step. This is the first step. 5x minus 7 is equal to t. Then what we have to do? Differentiating with respect to x. We have to differentiate with respect to x. So what will happen? 5x will become 5. For 7 it is 0. And then t will become dt by dx. It will become dt by dx. So here we can write dx is equal to dt by 5. Dx is equal to dt by 5. This is the first portion. Now in second part, what we have to do, since we have taken 5x minus 7 as t, so we can put here t to the power of 7 and then dt. So what is the integration of t to the power of, 3 is there. So t to the power of 3 is there. So what is the integration of t cube? It will become t to the power of 4 divided by 4. Divided by 4. And then plus c. Now at last what we can do, substitute the value of t again. So 5x minus 7 to the power of 4 divided by 4 and then plus c. And then plus c. Okay. So this is the result. And this method is known as substitution method. And now comes the shortcut. So do you want to know the shortcut? Because this process is the substitution method. You have to write 3-4 steps and then solve. But there is one shortcut which is available here. We can apply that shortcut as well. So now let us understand the shortcut. So we are applying shortcut in this second question first. Since we have to integrate 5x minus 7 to the power of 3. So first of all, we will treat the complete value as x. We will treat the complete value as x. So what will happen? X to the power of 4 divided by 4. So we will write this as 5x minus 7 to the power of 4 and then divided by 4. And then what else? Okay, one more thing we had left in that part is we had written dt. It was dt by 5. So we have to write here 4 into 5 and then it will become 20. So just make one correction here. Okay, it was 20. 5x minus 7 to the power of 4 and then divided by 20 because dx is equal to dt by 5. So here we have to write dt by 5. So that is why we are writing 5 and it become 20. Okay, so now focusing on the shortcut. Focusing on shortcut, the power will increase by 1 and divided by the same power. And now the main step. The main step is, what is the derivative of 5x minus 7? 5x minus 7, derivative of 5x minus 7. It is simply 5. So divide with that derivative. That is divided by 5. So it will become 5x minus 7 to the power of 4 divided by 20 and then plus c. This becomes the answer and this is the shortcut. All right. So let us apply this same shortcut in the first part also. 2x plus 3 whole to the power of 7. So first of all, treat the complete value as x. So it will become 2x plus 3 whole to the power of 8 divided by 8. Now, what is the differentiation of 2x plus 3? It is simply 2. So divide by 2. So we are getting 2x plus 3 to the power of 8 divided by 16 plus c. plus c. So this becomes the shortcut. Okay. So Divya has understood. Great. Lakshmi says your teaching is very much understandable. That's great. Thank you so much. So this method was substitution, and after that we had applied the shortcut as well. Now let us try one more question. X cube divided by x square plus 1 whole to the power of 3. So this time integration of x cube divided by x square plus 1 whole cube and then dx. Now here also we can let one of the function as t. So if we let x square plus 1 as t, x square plus 1 as t, if we have taken, then what is the next step? Differentiating with respect to x. So x square will become 2x, 1 will become 0, and t will become dt by dx. dt by dx. And this dx can be written as dt upon 2x. Now here the problem is the dx should come in terms of t, but here we are getting 2x. So we have to convert this x into t also. So how to convert? We have to focus on this as well. So one thing can be done. We can send this with dx. That means we will put with dx only. So let's do this. We can write x dx is equal to dt by 2. All right. We can do it. X dx is equal to dt by 2, and we can substitute the value of x dx. So in this question, we can write it as x square into x. This is x cube. So we have taken a bit splitting system. We have splitted them, and after that x cube plus 1 divided by 3 dx. So x square plus 1 is there. So in denominator, x square plus 1 can be written as t, power is 3. X dx can be written as dt by 2. So we will write here dt by 2. Now what about x square? So from here, x square can be written as t minus 1. So we can write here t minus 1. T minus 1. So what was the first step? First step was to let x square plus 1 equal to t. After that, differentiating both sides with respect to x. After differentiation, we got x dx is equal to dt by 2. And then we had substituted the values. Now easily we can split them. So it will become t upon t cube minus 1 upon t cube, 1 upon t cube. Now 1 by 2 is common for everyone. So we can take outside 1 by 2, and here it is dt. Okay, or we can write dt with them only. So let us do some cancellation if possible. So t and t get cancelled. So what is left? 1 by 2. Then t to the power of minus 2 plus 1 divided by minus 2 plus 1. Then t cube. So t to the power of minus 3 plus 1 upon minus 3 plus 1. And then plus c. So what is left Let's check. It will become minus 1 upon 2 and then t to the power of minus 1. Then plus 1 upon 4 t to the power of minus 2 plus c. And this can be written as 1 upon 2t plus 1 upon 4 t square plus c. And the value of t is what we have let it, x square plus 1. So in place of t, we can write x square plus 1. X square plus 1. So this is the final result. All right. So the main important step was first step to assume t. Then second step was to differentiate them. This was the first step, taking them t. Second step was differentiating them and to find x dx equal to dt by 2. Then third step was to split them. X cube, we have splitted them and written as x square multiplied by x. So that x dx becomes dt by 2. And x square can be written as t minus 1. After that, we have separated them. So it becomes t by t cube and then 1 by t cube. After that, we have simply done integration slowly and reached the final outcome. Okay. So in this last step, there is one square also. We'll write here square. All right. So before moving towards the next concept, let us take a small break for 5 minutes. And after that, we will continue. Okay. So welcome back everyone. So now let's proceed further and let's see if anyone is having doubt till here. Let's see. Pushdeep Kaur is asking, can you help me to come out with step number 6 of the second example? Step number 6. So 1, 2, 3, 4, 5, 6. I think which step you are asking? This T1, this step. This step was we have substituted the values. Since x square plus 1 is equal to t, so this was the case. So x square can be written as t minus 1. So that is why we have written here t minus 1 and then divided by t cube and then divided by t cube. After that we have done splitting. So t becomes divided by t cube and then it becomes dt by t cube. So in this way we had done the splitting. Then after that t got cancelled. So final will be t dt by t square and here dt by t cube. So the result is t to the power of minus 2 plus 1 upon minus 2 plus 1 and here also t to the power of minus 3 plus 1 upon minus 3 plus 1 and half is common in each and every step because half was already available outside. Okay, and at last we had applied plus c. So in this manner we had done the integration. All right. Okay, so now we are moving towards the next level of formulas. So let us discuss some more formulas and try to learn immediately. All right. So the first one says dx by x square minus a square. So it is similar to a square minus b square in denominator, but the formula is different. It is 1 upon 2a. First step is write 1 upon 2a. Then log. Then what is the formula for a square minus b square? It is a plus b and then a minus b. So since minus is here, we have to write x minus a in numerator and x plus b in denominator. X plus b in denominator. And at last we will write plus c. All right. This is the first formula. Now the second one. Second one is just reverse of this. Dx divided by a square minus x square. So since it is similar, we will write 1 upon 2a. Log is there and a minus x is there. So we'll write a plus x divided by a minus x and then plus c. Plus c. This is the second formula. Now comes the third one. Third one is having root. Third one is having root. So dx divided by root of x square plus a square. So here the formula will be log and then x plus root of x square plus a square and then plus c. Log bracket x plus root of x square plus a square plus c. And in case if there is a minus sign in between, then we will also put the minus sign. So x square minus a square. it will become log of x plus root of x square minus a square. So there is minus sign in between. This was the fourth formula. Then the fifth one. Fifth one is integration of. If there is one system such that in bracket fx and its differentiation both are written, and outside this bracket there is e to the power of x dx. This is the situation. Okay, what is the situation? One function is there, plus the derivative of the function is available here only, that is f dash x, fx plus its derivative f dash x, and outside bracket e to the power of x is written. Then what will be the result? Its result will be e to the power of x multiplied by fx plus c. E to the power of x multiplied by fx plus c. This becomes the fifth formula. Now the sixth one, root of x square plus a square. Now this can be written as x upon 2 root of x square plus a square. Now this is a bit lengthy formula. So first of all, we have written root x square plus a square as it is, multiply it with x by 2 plus this time a square by 2, then log of x plus root of x square plus a square plus c. So from here, it is the same formula which we have written in the third and fourth one. So it is exactly similar to the third formula. So from here, it is the third formula, and this one was from the question itself. So what is left? Simply x by 2 and a square by 2. Remaining is from that formula only. All right. And then we have to reach the next one, seventh. Seventh one is minus subtraction root x square minus a square dx. So x by 2 root x square minus a square will be there. Then again minus will be there, a square by 2 log of x plus root of x square minus a square and plus c. So we have put the minus sign at first place, then second place, and then third place. At 3 places, we have inserted the negative sign, and rest the formula is same. Okay. Then the last one is eighth one, f dash x divided by fx. That means function is available in denominator and its differentiation is available in numerator. So in that case, the result will be log of fx plus c. Log of fx plus c. So Divya is asking why we are using fx and not f dash x. See, after integration, we are again reaching to the function. What we discussed in our first 5 minutes was whenever we are having a function fx, after we are having f dash x, after integrating, it becomes fx. In the first one, we discussed when function is there, we differentiate, it becomes f dash x. And if we integrate f dash x, we again reach to function. So after integration, we are always reaching to the function that is fx. So that is why we are writing fx, okay, and not f dash x. Kushdeep is asking, I didn't get the sixth one. See, these are all the formulas. We have to learn this, but I had told that as it is, if we try to connect them, then it becomes easy to learn. It becomes easy to understand. So what we discussed in the sixth was root of x square plus a square is taken as it is. Then we have multiplied this with x by 2. After that, again, we have taken this portion from third formula and then multiplied with a square by 2. So in this way, you can connect the formula. You can have a bond between the formula and then learn. All right. So let us try one question. So this time we are having integration of e to the power of x divided by e to the power of 2x and then minus 4 and then minus 4. So in denominator, we can see that it is e x to the power of 2 and 4 can be written as 2 square. So in denominator, we are having x square minus a square form. But in numerator, we are getting extra e to the power of x. So how to remove that and how to apply the formula? So here we can let e to the power of x is equal to t. We have taken e to the power of x as t. Now what will happen? If we differentiate it, it will become e to the power of x is equal to dt by dx. So in place of dx, we can write dt upon e to the power of x. All right. Now here we can write integration. In place of dx, we are writing dt by e to the power of x. So dt upon e to the power of x. Then in denominator, we are having e to the power of 2x. This can be written as t square minus 2 square. Now we can see that e to the power of x will get cancelled. So we are left with simply dt upon t square minus 2 square. So we can apply the formula of integration of x square minus a square. So it will become 1 upon 2a, 1 upon 2a, a is simply 2, then log of x minus a upon x plus a and then plus c. This was the formula. So 1 by 4 log of, in place of t, we can write e to the power of x minus 2 upon e to the power of x plus 2 and then adding c. And then adding c. All right. Now the next one, integration of 1 divided by x plus root of x square minus 1. So now this is a bit of different one, but there is one trick which we can apply here. So let's make some space first. Yes. So now we are having this question, integration of 1 upon x plus root of x square minus 1. Now it seems to be complex one, but if we try to recall, there was one thing, rationalization method in lower classes. Class 9, 10, 10 we did rationalization. Whenever root was available in denominator, we try to rationalize. So similarly, here also we try to rationalize them. So how do we rationalize? We will write x, then minus root of x square minus 1 divided by x root of x square minus 1, and at last dx. So how do we rationalize? We just change the sign. Just change this sign. Instead of plus, we have taken minus. Rest all should remain same. So in this way, we have done rationalization. This is minus and here it was plus. This is the difference. Now, after doing this, what will happen? The numerator will remain as it is. And in denominator, there will be one applicability of formula a plus b and a minus b. So it can be written as a square minus b square. So here we will write a square minus root of x square minus 1 square. This is the b square. So a square minus b square we have written. Now, if we try to open this, what will happen? X minus root x square minus 1 upon x square minus x square and then plus 1. So x square is getting cancelled and we are left with only plus 1 in denominator. So it means we are already only having numerator and there is no denominator. And now we can apply the formula. Now you can see which formula is applicable out of all these. So you can easily see that x is getting separated. X is getting separated and then root of x square minus 1. So we can apply root of x square minus a square. That is formula number G. Formula number G can be easily applied here. So integration of x becomes x square by 2 minus. Now what is the formula number G? We can easily apply here. That is x upon 2 root of x square minus a square. So x square minus 1 and then minus of a square by 2. So what is a here? A here is simply 1. So it is 1 by 2 log of x plus root x square minus 1 and at last plus c. So here we had applied the formula number G. Okay. So let us discuss once again. So what was the first step? First step was to rationalize, that is multiplying with the same value but with different sign. After that, we applied the identity a plus b, a minus b. It becomes a square minus b square. So after applying this, we are left with only numerator. There is no denominator. There is no denominator. And after that, we are done. We had applied the formula number G and got the result. Okay. So Divya says clear, Bhumika says understood. That's great. So this was example number B. Now similarly, we can try one more, that is C part. That is a bit different one. Okay, Kushdeep is asking, it's so lengthy. So do these type of question come in exam? See, in overall 100 question, not all lengthy questions will come together. But yes, some of the lengthy questions will come. It can be from any chapter. Sometime it can be from this chapter, sometime from any other chapters. But on an average, only few questions are lengthy. Most of the questions are of medium length and few questions are of very short length. Okay. So not all questions are lengthy, but some of the lengthy questions will come. So C part. C part says integration of e to the power of x and then x cube plus 3x square and then dx. Now this is again one formula which we can easily see that x square is the function, x square is the function and its derivative is 3x square. So x cube is the function and its derivative is 3x square, that is f dash x, and outside this bracket e to the power of x is written. So it is the same situation. So we can directly write the answer e to the power of x and then x cube plus c. This is the answer. Okay. Then next come integration by parts. Integration by parts. That means whenever there are two functions getting multiplied with each other. That means similar to what we did in differentiation, that is product rule. Two functions were getting multiplied, so we had to apply the product rule. Here also, if two functions are there in multiplication with each other, we can apply integration by parts. So how to apply and how to form the formula, let us understand. So there are two functions, one is u and second one is v, and we have to integrate them. So we can write u and then some space v dx, then put the minus sign, again put u, then some space v and then put dx. Okay, u v dx minus u v dx. After that, what to do? Between u and v, make the integration symbol. Here also between u and v, this is the integration symbol. This we have done. Now the next step is we have to write one more integration symbol, that is after the minus sign. After minus sign, put integration, then also put one bracket, then d by dx, then bracket close, and then again dx. So this becomes the formula of integration by parts. Integration by parts. That means this formula want to say that whenever you are having two functions, the first function will remain outside. We will not integrate the first function. It will remain outside. Then v is the second function. We will integrate the second function. This is second function we will integrate. Minus. Now again the first function, we are differentiating it first. Before integration, we are differentiating the first function and then integrating the second function. So we are integrating the second function. And at last, whatever result is coming, we have to integrate that. So in this way, this is the formula for integration by parts. All right. So the first step was to write u integration v dx minus, again writing integration v dx, and after that we have to write integration d by dx and then bracket close and dx. So this is the formula for integration by parts. Now, what should be the first function? What to assume the first function? So whenever there is some question, like let's say there is one question, find integration of x and e to the power of x. Okay. Then which function should be taken as first and which should be taken as second? So for this, you can remember a word that is LIATE. LATE. You can remember this word LATE. L means logarithm, log. A is for algebra. T is for trigonometry. And E is for exponent. E is for exponent. So we have to use them in order as first and second. If let's say log and algebra is there, if log and algebra is there as two functions, then log will be taken as one, algebra is second. Trigonometry is not in our syllabus, so we don't have to compare with trigonometry because this is not in our syllabus. Then let's say log and exponent is there. Log and exponent is there. So log can be taken at first, exponent will be second. If algebra and exponent is there, algebra will be first, exponent will be second. That means as per this sequence, we have to take the priority. Okay. Omega says it is I late, but yes, I is again is not usable here. That is why we have skipped I, because I means inverse trigonometry function, and that inverse is not in our syllabus. All right. So that is why we have to just remember LATE, LATE. So L for log, A for algebra, T for trigonometry, and E is for exponent. So integration of x e to the power of x. So x is algebra, e to the power of x is exponent. So we will take x as first function, e to the power x second function. So let us apply the formula. First is u will remain outside, so x is outside. Then integration of e to the power of x dx minus integration sign dy dx. Now again write u integration e to the power of x dx bracket close and then again dx. Now let's solve this. X will remain as it is. Integration of e to the power of x is same minus. Now this time derivative of x is 1. Then integration of e to the power of x is e to the power of x. And at last dx. So finally we are getting x e to the power of x minus integration of e to the power of x is same, and we will write plus c. So this becomes the formula. This is the final result. All right. Let us try one more question from this. Integration x log x. So as per LIATE, who is coming first? Log is coming first. So log is the first function and algebra is the second function. So taking log x integration x dx minus integration d by dx of log of x, then integration of x dx. Okay, first of all, arrange the values in the formula. After arrangement, we can solve. So log of x, then x. Now integration of x becomes x square upon 2 minus derivative of log x. Log x is 1 by x. Integration of x, x square upon 2. So here we can see that x can get cancelled. So let us simplify some more. So it will become x square by 2 log of x minus half. Now integration of x is x square upon 2 and at last plus c. So the final result is x square by 2 log x minus x square upon 4 plus c. So this is the final result. Okay, Priyanka has joined the session now, saying good afternoon. So after this, the third one, let us try third also. Okay, there is message from Priyanka that I have come here to thank ICI and live lectures provided, and I could clear my CA foundation exam in first attempt with your help. That's great, Priyanka. Congratulations. Very good to hear that you have scored good marks, and hope all those students who are pursuing CA foundation now should also score good marks and clear in first attempt, that is in 2022. That's great. Now the third one, integration of x square e to the power of ax. Now, which is the first function? LIATE, as per LIATE, LATE, exponent is coming last and algebra is coming first. So algebra is first function, exponent is second function. So let us do this. X square, then integration of e to the power of ax dx minus integration d by dx of x square and e to the power of ax dx. Now what will happen? X square integration of e to the power of ax is e to the power of ax divided by a minus differentiation of x square, that is 2x, integration of e to the power of x, e to the power of ax upon a, and then it is dx. Now here, if we see that, again we are having two variables getting multiplied together. Here in this step, x and then e to the power of ax. So again, there are two variables. So we have to apply integration by parts once again. That means in some questions, we have to apply two times. So let us try to apply one more time. So x square e to the power of ax upon a, this is outside. We can take constant outside the bracket. Now apply the integration by parts one again. X is the first function, integration of x is the first function, then integration of e to the power of ax dx minus again integration d by dx of x, integration of e to the power of ax dx. And then dx. So again, simplifying these. So 2 by a is already common. X will remain as it is, e to the power of ax divided by a minus. Now this time differentiation of x is 1, e to the power of ax dx. This will become e to the power of ax upon a. And then we have to integrate it one more time. So x square e to the power of ax upon a minus 2 upon a square and then x e to the power of ax. Then minus minus will become plus 2 e to the power of ax divided by a cube and then plus c. So this becomes the final answer. All right. So in this question, we had applied integration by parts two times. So we have learned many concepts and many formulas today. So it is so much important and very much important to revise the today's session. And also remember each and every formula. If you forget today, it will become again difficult to learn next time. So it is better to learn all the formulas completely and you can write them once without looking into the book. Okay. So if you are able to write all the formulas without copying, that means you have already learned the formulas by heart. And if you haven't learned all the formulas, then first of all, try to learn and then write all the formulas accordingly. Okay. So the next concept we will be doing in the next session, and from the back questions, we can discuss which questions at least you can try for your homework session. So it becomes easy to apply the formulas. Okay. So the first one, First one is very much easy. Options are there and you can see which option will be correct for the first question. Integration of 5x square. You can take 5 outside. Then integration of x square dx. It will be 5x cube upon 3 plus c, or here in the option k is given as constant, so you can write k. So which option is correct? Option number B. Option number B is correct. Similarly, question number 2. Now I think you can do it directly in one step, and orally you can take the correct option. For 3, it will become 3x minus 2x. For minus 2x, it will be x square upon 2, and 2 and 2 will get cancelled. So it will be minus of x square. Then x to the power of 4. So it will be minus x to the power of 5 by 5, and then plus k. So option number B. So Gunjan Devi has given the answer option B. Tejasri has also given the answer option number B. Great. So new answers coming from new students. That's great. Then the third one, function is given and then we have to integrate the function. So this third you can try. Fourth is again very much easy. You can try. In question number 5, what needs to be done? First, do multiplication. After multiplication, integrate all the values separately. So 5 you can try. Then sixth one is again very easy. 7th, 8th. In 8th, you can apply the shortcut method as we have discussed. You can tell the answer now for question number 8. If the function is 4x plus 5 to the power of 6. And now you have to answer what will be the integration. 4x plus 5 to the power of 6. So the first step was to write 4x plus 5 as it is, with increased power, divided by 7, and also divide by integration, that is, sorry, differentiation, which is 4. So it becomes 1 upon 28, or 4x plus 5 to the power of 7 upon 28. So this option is available with A. Option number A. Anushya Bhatt has also given the answers, Divya, Lakshmi, and Bhumika. So correct is option number A. Then 9 you can try using substitution method. Then question number 10, you can tell this orally. X plus a to the power of n. What will be the result? Very simple question. Question number 10. Let's see who gives the answers for question number 10. So here again you have to apply the shortcut. Yes, Lakshmi, Bhumika, A option, Divya, A option. Yes, option number A is perfect. For 11th, you can again apply the substitution method. 12 is partial fraction, we have not done, we will do in next class. Then integration by parts we have done, so you can try question number 13. 14 is very simple. You can try this. Fifteen is integration by parts again. Then definite. 22 you can try. Then the next one, 27 can be done. Then the next one, 45 you can try. 46 can also, 48 can also be done. This much only. So all those questions which I have made you mark, you can try all these questions. And I think you will be able to solve all these questions very easily now. And this chapter can become just like a cake. Very soft and easy chapter. The main thing is you have to learn all the formulas, you have to apply all the formulas, and then it becomes very easy. So guys, it is almost end of August now, and we are having only few months left. So it's time to revise all those chapters which you had done previously. So never ever forget to do the revision. So all those chapters which you have done for mathematics, because this is the last chapter of maths, and after this chapter we will be starting with logical reasoning. So till that, you can try to revise all the chapters thoroughly by yourself. Take yourself a test so that you yourself know better. आप खुद को खुद से ज़्यादा अच्छा पहचान सकते हैं ताकि आपको आइडिया रहे which questions you are able to do and which you are not, and try to make improvement on daily basis, regular basis. Make your proper timetable so that you can score good marks. All right. So I think we have done everything today. So bye everyone. Take care and see you in the next session. Okay.